A heavy steel door stood in the middle of a blank white room. It had no keyhole, no keypad, just one strange inscription: x squared minus 5, x plus 6 equals 0. Stickman searched every corner for another clue, but there was nothing. The only way through was to solve the equation. He tried guessing numbers. 2, 3, 4. The door didn't move. It was as if the equation wasn't asking for one answer, but hiding multiple secrets. That was the first clue. Most equations ask for a single missing value, but quadratic equations play by different rules. They often hide two solutions, and discovering why turns out to be one of the most satisfying mysteries in mathematics. Stickman noticed the highest power of x was 2. That tiny square changed everything. A squared variable doesn't produce a straight path. It creates a curve, and curves have a strange habit. They can cross the horizontal axis more than once. Could that be why the door expected more than one answer? Instead of guessing, Stickman broke the equation into pieces. What two numbers multiply to give 6, but add up to minus 5? After a moment, the answer appeared: minus 2 and minus 3. The equation transformed into two smaller clues. Open parenthesis, x minus 2, close parenthesis, open parenthesis, x minus 3, close parenthesis, equals 0. Now another mystery appeared. How can two expressions multiplied together equal 0? The answer lies in one of mathematics' simplest but most powerful rules. If the product of two numbers is 0, then at least one of them must already be 0. 0 refuses to hide. It forces one factor to vanish. So either x minus 2 equals 0 or x minus 3 equals 0. That meant x could be 2 or 3. The steel door clicked open, but instead of freedom, another room waited. This time the wall displayed a graph shaped like a giant smile. The equation from before was now drawn as a smooth U-shaped curve. Stickman marked x equals 2 and x equals 3. Those exact points were where the curve touched the horizontal axis. Suddenly, everything connected. The algebraic answers weren't random numbers. They were the places where the graph reached a height of 0. Solving the equation and finding where the graph crossed the x-axis were actually the same mystery viewed from two different angles. Then something unexpected happened. The next door showed a new equation. X squared minus 4, x plus 5 equals 0. Stickman repeated the same strategy. He searched for two numbers that multiplied to 5 and added to minus 4. Nothing worked. He checked again. Still nothing. Had the method failed? The graph appeared beside the equation. This curve floated completely above the x-axis without touching it even once. That explained everything. Some quadratic equations never cross 0, so they have no real number solutions. The graph wasn't broken. It simply never reached the horizontal axis. The mystery wasn't about bad algebra. It was about geometry. Then another equation arrived. X squared minus 4, x plus 4 equals 0. This time, the factors became open parenthesis, x minus 2, close parenthesis, open parenthesis, x minus 2, close parenthesis. Only one number appeared. Yet the equation was still quadratic. How could an equation that usually hides two answers suddenly have only one? The graph revealed the trick. Instead of crossing the x-axis, the curve gently touched it and bounced away. Both hidden solutions had merged into the same point. Mathematicians call this a repeated root, but visually it's simply a curve that kisses the axis instead of cutting through it. Three different equations. One crossed the axis twice, one never reached it, one touched it exactly once. The pictures explained what the symbols couldn't. Stickman thought the investigation was over. He was wrong. A final machine appeared with hundreds of different quadratic equations flashing across its screen. Solving each one individually would take forever. There had to be a universal key. That's when mathematicians discovered something extraordinary centuries ago. No matter what quadratic equation appears, as long as it's written in the standard form, ax squared plus bx plus c equals 0. There is always one formula capable of unlocking every solvable case. The quadratic formula wasn't invented to make life complicated. It was created because factoring doesn't always work. Some equations refuse to split into neat pieces, but the formula still finds every possible solution. Even more surprising, hidden inside that formula is a small expression called the discriminant, b squared minus 4ac. Before solving anything, it predicts the entire story. If it's positive, expect 2 real solutions. If it's 0, expect 1 repeated solution. If it's negative, there are no real solutions at all. The machine wasn't testing arithmetic. It was testing whether Stickman understood the pattern behind every quadratic equation. The screen turned green. Every lock opened. And the greatest surprise wasn't that the equations had been solved. It was that what first looked like random symbols were actually describing the shape of a curve, the behavior of numbers, and the geometry of solutions all at once. That's the real secret of quadratic equations. They aren't just formulas to memorize. They're different ways of telling the same mathematical story through algebra, graphs, and logic. The next time you see an equation with x squared, don't rush to find the answer. Ask what story it's trying to tell. Because somewhere inside that curve, another mathematical mystery is waiting to be uncovered. Join us for the next investigation.